Hello, my name is Andre, and today I'm going to show you how to upgrade your Talos cluster. In this video, I'm going to upgrade a Talos cluster from latest stable release 0.6.2 to the latest alpha 0.7 alpha 7 available at the moment, but the same set of steps apply to any Talos upgrade. The upgrade will consist of two major steps. The first step is to upgrade the Kubernetes control plane, and the second step is upgrading the Talos operating system itself. Let's get started. So here I have a cluster running in virtual machines on my computer. It's running Talos version 0.6.2. We can verify that by pulling list of the nodes with kubectl. We can see we have 3 master nodes and 1 worker node. The kubelet version is 1.19.0. That's the default kubelet version shipped with that version of Talos, and version 0.6.2 here. So what I'm going to do first is to upgrade the Kubernetes control plane because with the Talos 07 we have updated version 1.19.3. So to start this process, I'm going to use the Talos CTL utility, which is a CLI utility used to access Talos clusters, and it has some helpers to upgrade the Kubernetes control plane. So I'm going to say Talos upgrade Kubernetes. I'm going to give it IP address of one of the nodes so that it can pull the Kubernetes config file to client config file to access the cluster. And I'm going to tell it from which version I'm going to upgrade, 1.0 to 1.93. That is the first step. I do it before the upgrading the Talos itself. So I'm starting this command. It pulls down the Kubernetes config and then starts working. Due to the way Kubernetes control plane is running on Talos, it's self-hosted and initially provisioned by Bootkube. There are some specific steps required to complete this upgrade, which are all wrapped into this upgrade Kubernetes utility. There is a special process called pod checkpointer. Let me show you on the same screen list of the pods running in kube system namespace. We can see that in addition to the regular API server, controller manager, scheduler pods, there is also something called pod checkpointer. As the control plane is self-hosted, pod checkpointer allows to recover the control plane in case if there is some kind of a failure to start the API server or controller manager or scheduler. But also pod checkpointer makes it a bit tricky to update the daemon sets, and API server, for example, is a daemon set. The same applies to kube scheduler or controller manager. So the first step we are doing is we are taking Kube API server out of pod checkpointer control first, so there will be no problem when we're going to roll out the daemon set update. And that requires us to wait for 5 minutes so that pod checkpointer itself it has a kind of a grace period of 5 minutes before it actually stops doing the checkpoints for the pods it manages. And while we're waiting for that, I'm going to talk a bit about the Talos upgrade itself, because the Kubernetes control plane upgrade process is more or less straightforward. What we're doing is just updating the daemon sets and basically updating the image reference to the new version, while upgrading the Talos itself is more interesting. The way Talos upgrades are implemented is quite unique. And in short, the Talos upgrade is equivalent to leaving or removing a node from the cluster and adding a new node back. But the upgrade happens in place. So when we trigger upgrade of Talos on a control plane node, what is going to happen is that node, as it is also part of etcd cluster, is going to leave the cluster, the etcd cluster. Everything is shut down on the node. The installer image, which is just a container, Talos installer, is going to be pulled from the internet, and it runs on the node, completely wipes the file system, installs a new version of Talos, and we get a completely fresh install as if it was just installed. Then it gets rebooted. And when the node boots once again, it joins back the cluster. So it successfully joins the etcd cluster, becomes once again a member, joins the Kubernetes control plane back. The node becomes ready. And once everything is healthy and we got the first node upgraded, we can proceed to upgrading other nodes. We do this first for the master nodes or control plane nodes, and then for the worker nodes. As you probably remember, we have 3 master nodes here and 1 worker node, and that's the order of the upgrade for us today. So we're still waiting. There is approximately 1 minute left for the pod checkpointer to grace period to expire. And what we can do, we can also take a look at the uh, daemon set in the kube system namespace, which we can get a list of daemon sets. We see there is a daemon set, like say, called kube API server. We can call describe on that to see how it gets configured and how it's going to be updated. So we can see that's a daemon set, and here is the image reference. We can see right now it's 1.19.0, and when upgrade Kubernetes command we started finishes, it's going to update basically those image references to the new version. And the kubelet itself will be updated with the Talos OS upgrade. It will be also, the version will be bumped to 1.19.3. So let's get back to the watch for the kube system pods. The process of update should start soon. So the first step is called temporarily taking kube API server out of pod checkpointer control, which means that right now what is happening is the kube API server is no longer will be checkpointed, and once that finishes, the upgrade Kubernetes command will be able to simply update the daemon set and perform a rolling restart of the kube API servers to the new version. It takes a bit of time once all the pods are restarted and all the checkpoints, the old checkpoints are gone. And the problem is that those checkpoints are preventing the kube API server from starting properly because they both try to listen on the same port for the API server. So basically pod checkpoint, the checkpoint which gets started is equivalent to the running pod, and it can work completely fine. But what we actually need, we want these checkpoints to be gone so that we can update, because the checkpoint is running the old version of the API server, and what we want is to have a new version here. So this process should be done pretty soon. We see probably the last kube API server, we have 3 instances because we have 3 master nodes, is going to be updated. And once they're all updated, the upgrade Kubernetes process goes to the next step. And now it's updating the kube API server daemon set itself to the new version. And once we'll go through all the steps and all the daemon sets are updated, this command is going to restore the pod checkpointer to the previous state. So it will once again start actively checkpointing the pods and creating them. but they will be created with the new version of Kubernetes, the one we got updated. After the API server, it moves to the Kube controller manager. So it's going to update the next daemon set. And after the Kube controller manager, then comes the turn of the Kube scheduler and Kube proxy. And once those components are fully updated, we can actually proceed with the updating the Talos control plane. So we're looking at the Kube control manager right now, which is being updated, and the pods are being restarted. It takes a bit of time. We at Talos plan to change the way the Kubernetes control plane is hosted in the near future, and this self-hosted experience we can improve on that because that's certainly not the best possible experience. So we're looking forward into getting it better and getting it easier to be managed. But for now, we developed this command so that the upgrade of the control plane is much more easier and much more automated and streamlined. So we're looking still at the Kube Control Manager to be updated for all the pods. We have probably 2 out of 3 pods ready after update, and still looking for the third pod to be available. After that, the update should move to the Kube scaler. We can see the third pod of Kube Controller Manager gets started, and we soon should move to the next step. Yes, so that's the Kube scaler. She's going to be also updated in a rolling restart, one after another. Let's give it a few minutes for the update to be finished. And this is the recommended sequence of steps to upgrade Kubernetes in general. First, we upgrade the control plane components, starting with the API server, and then as the last step, we upgrade the kubelet. The kubelet is going to be upgraded automatically with the Talos upgrade because the way my Talos cluster is configured here, it follows the default version of Kubernetes for the Talos release, but of course, this can be also configured in a different way. We can run a different version of kubelet or don't upgrade. We can skip upgrading version of kubelet while upgrading Kubernetes. That is also possible. It just depends on the configuration of Talos. But in my case, like I said, it's just using the defaults for each version. So whenever I upgrade Talos, it's going to update the image for the kubelet as well. So the last step, so we have the control plane updated, is updating the pod check pointer grace period. So basically restoring the previous settings of the pod check pointer so that it will continue to protect the control plane. You can see that pod check pointer is being restarted as well in the list of the pods. And once it's all done, we should be ready to start the Talos upgrade process. So we're going to do this here, and I'm going to show you the list of the nodes so that we can see how upgrade moves through. Like I said, the initial state, like we had, is we have 4 nodes all on Talos 062, and we're going to issue the first upgrade command. So talosctl upgrade. I'm starting with the first control plane node, which has in my case IP 10.502. And I'm going to give the reference to the installer image. This reference could be found on the Talos GitHub. For each release, there is a list of images, and we can simply get this reference to the installer image there. I'm giving it the reference and pushing enter to start the upgrade and tell us what it does. It verifies the image at the moment, and if everything is fine, the upgrade is started. It replies back with the acknowledgement that upgrade process got started. And in the list of nodes, we can see that immediately this master one node, the first one, which I'm upgrading, is getting drained. So it's scheduling disabled, and the Talos is working on the upgrade. As in my case, all these nodes are running locally on my computer. What I can also do, I can look into the logs for this specific node to see how the update is proceeding. If it was like a bare metal hardware, I could have looking at serial console logs. Let's see what's going on there. Actually, upgrade also already finished, and it's the new version of Talos booting now. Let's see how it goes. So it joins back the etcd cluster and it's going to run the kubelet, and the kubelet is going to start all the other control plane components. We can see that etcd is healthy, and we can also see in this kubectl get nodes that the node got actually upgraded. So it's now running 0.7 0 Alpha 7 of Talos, new Linux version, and the kubelet got updated and the containerd got updated. And the node is now fully ready, which means that CNI got started, the Talos finished successfully the upgrade, and what we can do, we can move on to the next node. So I'm going to run the same upgrade command, just changing the IP address to the next master node. And as soon as I'm doing that, the node will get drained. And what we can do this time, we can watch the logs early so we can see what's going on. So what's going on now is the node is being drained. So we can see that Talos is removing the running pods and containers on this node. And this process takes a bit of time before all the containers are terminated, before the upgrade starts. Let's give it a few. And once all the pods are removed and all the processes are stopped, the uh, the file systems are unmounted. So basically now it gets into this clean state. We can see it unmounts all the partitions and then performs the actual upgrade by running the installer container image. And this image is going to repartition the hard drive by wiping all the partitions, formatting them clean, writing back the kernel image, initramfs image, and Talos is fully self-contained in this initramfs read-only image, writing bootloader configuration, configuring that, and after that stopping all the remaining services which are running from the RAM disk and actually rebooting. And now the node got booted, and you can see while I was talking, it got upgraded and it's ready. So we're good to go for the next node. It's going to be node .4. I'm showing you how to run this process manually using talosctl, but of course, as this is all API based, this process can be easily automated. And at Talos, we have a project, we call it right now upgrade controller, which can run next to the Talos cluster and actually help perform the upgrades in the right order, in the correct sequence, verifying the cluster health between the upgrade steps. And basically, you no longer have as an operator worry too much about upgrading your cluster. It will be fully automated. Or of course, you can implement your own automation with whatever maintenance windows or other specifics related to your workflow required for that. So right now, the third master node is being upgraded. We're waiting for that, and we can see what's going on here. And actually, the new node got already booted, and now we're waiting for the Kubernetes components to be running. You can see that it is marked as ready, and soon it's going to be concordant. We're all good to go, and we have the last node, which is a worker node, to be upgraded, and that should be the last step. Worker node is a bit easier to upgrade as it's not part of the etcd cluster. There are less steps, basically just draining the node, running the installer, rebooting the node, and it joins back the cluster. And it's completely clean, new, and we can just enjoy this process, how easy it is. Let's look into the logs for the worker node. If I had more worker nodes, of course, I would have to repeat this process for every node. So it's still being drained at the moment. We can see it's removing the running pods on the worker node. What we can also do, we can take a look at the uh, running pods, for example, in our cluster, how things are looking as we are going through the upgrade. And we can see that we have a full HA control plane still. Everything is running. Every pod which is expected to be there is still there. So it looks good. And this node is, the worker node is being now probably rebooted. And actually it got back. You can see how fast it is. It's now going to join the cluster. You can see the information already got updated. So I have now all the nodes running the Talos version I was looking for. The kubelet version is updated. Linux kernel, everything is up to date. Now all the nodes are back. What I can also do, I can use the talosctl to verify the cluster health. What I have to do is to give the one of the node IP addresses and launch the health command. And the actual health check is going to run on the server side. It's going to discover the nodes in the cluster. That's my control plane and one worker node. And then it does set of checks for critical system services like etcd, API-ID, Kubernetes nodes, Kubernetes control plane, that all the components are healthy and running as expected. And so by now, I've got the upgrade fully done, and I can move on to something else. Thanks for watching. Goodbye.